We're on problem 9. Use the problem below to answer the question that follows. Given that 100 milliliters is equal to approximately 0.4 cups, 205 milliliters is equal to approximately how many cups? So we could set up a little ratio here. We could say 100 milliliters is to 0.4 cups as 200 milliliters, I'll write the cups here, is to how many cups, just like that. And so we just have to solve for x. To solve for x, we can essentially cross multiply, which is essentially just multiplying both sides of the equation by both denominators. So we get 100x, 100 times x is equal to 200 times 0.4 is equal to, well, it's not 200, it's 205 to be exact. 205 times 0.4 is equal to 205 times 0.4. And then we want to divide both sides by 100. So x is equal to 205 over 100 times 0.4. Let me write a little bit different. 0.4, just like that. We could have divided either by 100, but let's see if any of the choices look like what we have there. Something times 0.4. Well, this one has subtraction in it, so that's not our answer. This one also has subtraction in it, not our answer. 105% of 0.4, that's the same thing as 1.05 times 0.4. 205% times 0.4, that's the same thing as 2.05 times 0.4, which is exactly what we have here. And just to verify, 205 divided by 100, I'll do it right here. 100 goes into 205. 100 goes into 200 two times. 2 times 100 is 200. Let me put a little decimal right there. You do the subtraction, you get 5. Bring down a 0. 100 goes into 50 0 times. 0 times 100 is 0. Do a subtraction, bring down another 0. 100 goes into 500 5 times. 5 times 100 is 500. It all evens out to 0. So you get 2.05. So this thing is the same thing as 2.05 times 0.4, which is the same thing as 205% of 0.4. Choice D. Next problem. All right. We are on problem 10. I'll switch colors. Use the number line below to answer the question that follows. Okay, we have a number line. What number is represented by point P on the number line above? Okay, so they give us two endpoints, 0.003 and 0.004. And how many buckets do we have between them? We're going one increment. Oh, sorry, I'm on the wrong layer. We go one increment, 2 increments, 3 increments, 4 increments, 5 increments, 6 increments, 7 increments, 8 increments. So over 8 increments, we go a distance of how far? Well, the distance we go is 0.004 minus 0.003, which is just 0.001. So this whole distance right there is 0.001. 0.001. And so each of these are an eighth of 0.001. Right? Let me do that in another color. Right? We have 1, 2, 3, 4, 5, 6, 7, 8. Don't want to make it any dirtier. So each of those are 1/8 of 0.001, or you could say it's 8 divided by 0.00, or 0.001 divided by 8 is how much each of these increments are. And the point in question is exactly 2 increments past 0.003. So let's figure out how far each increment is. It's 0.001, which is this entire distance, divided by 8. And the best way we can do this, well, let's just put a decimal right there. 8 goes into 0, 0 times. 8 goes into 0 times 8 is 0. Bring down a 0. 8 goes into 0, 0 times. Bring down a 0. 0 there. Bring down a 1. 8 goes into 1. 0 times. 0 times 8 is 0. Bring down the 1. You could bring down another 0. And now it gets interesting. 8 goes into 10. 1 time. 1 times 8 is 8. 10 minus 8 is 2. Bring down a 0. 8 goes into 20. 2 times. 2 times 8 is 16. 20 minus 16 is 4. Bring down another 0. 8 goes into 40 5 times. So it's 0.000125. And you might already know that 1/8 is equal to 0.125. That's something you might just know from heart. And so if you have this divided by, this isn't, we're not dealing with 1/8, we're dealing with 0.0018. So with this divided by 1,000, you're going to have 3 zeros and then, and then your 125. So that's how much each increment is, and we're going 2 of these increments just like that. So if you multiply this times 2, what do you get? You say 2 times 125 is 250, but we have 1, 2, 3, 4, 5, 6 numbers behind the decimal point. So 1, 2, 3, 4, 5, 6. We have to have 6 numbers behind the decimal point in our answer. So that's how much we move for above 0.003. So essentially, so this is going to be 0.000125, another 0.00125, and it's all above 0.003. So our answer is going to be 0.003 plus this, plus 0.003, which gets us to 0.00325. And so that is 0.00325. And I just realized there was an actual much easier way to think about it. Instead of dividing by 8 and all of that, I could have just said, you know what? There are 8 increments here. I made this problem messy, but there are 8 increments here. 1, 2, 3, 4, 5, 6, 7, 8. We've gone 2 of them. So we've gone 1/4 of the distance between 0.003 and 0.004. And that would have been the easiest way to do the problem. 1/4 of the distance is just another 0.25. And that would have been way easier to do the problem, especially if you didn't want to waste a lot of time. Problem 11. A book distributor is trying to divide an order of textbooks into equally sized groups for shipping in cartons. The textbooks can be divided into groups of 12, groups of 15, or groups of 18, with no books left over. So that means that the number of books we have is divisible by these 3 numbers. Which of the following inequalities is satisfied if n is the smallest possible total number of textbooks? So essentially, we know that n is divisible by these 3 numbers, and we want to find the least possible n that's divisible by these 3 numbers, or essentially the least common multiple of, so we want to, let me write this down, n is equal to the least common multiple of 12, 15, and 18. And the easiest way, for at least for me, to think about this type of a least common multiple problem is to just take the factors of each of these numbers. Let's take the prime factorization of these guys right here. So 12, if we want to take the prime factorization of 12, it's, let's see, we could do a little tree here, but it's pretty easy. It's 4 times 3. 4 is the same thing as 2 times 2 times 3. That's 12. So if we just had the least common multiple of just 12, we would say, well, I have to have a 2 in it times a 2 times a 3. So we have other numbers here. We have a 15. We'll do another color. 15. 15 is equal to what? Its prime factorization is 3 times 5. So in our answer right now, we already have a 3 as a prime. So to make this divisible by 15, we just have to include the 5 only. So 3 times 5. So this number right now is now divisible by both 12 and 15. How do I know? Because all of 12's constituent factors, or its prime factors, are in this number. And all of 15's constituent numbers are in this number. So this right now is the least common multiple of 12 and 15. And then we can throw 18 into the mix. So 18, that's the same thing as 2 times 9, or 2 times 3 times 3. And our answer here, we already have a 2 times 3, so we already have these 2 constituents, but we need another 3. So let's multiply by another 3. Now this is going to be the least common multiple of 12, 15, and 18, because it has all of the constituents of all of these guys. You have 1, 2, and 2 3s, 1, 2, and 2 3s, a 3 and a 5, you got a 3 and a 5, 2 2s and a 3, 2 2s and a 3. You have all the prime factors of all of these guys, and now you can just multiply. See, 4 times 4, 2 times 2 is 4, times 3, let me do it, times 3 times 5 times 3. 4 times 3 is 12, times 5 times 3, 12 times 5 is 60 times 3, which is equal to 180. So that is the smallest total number of books, the least common multiple of these. And that means that's choice B. 180 is between 150 and 200.